Hello, my name is Chelsea Scott, and welcome to this OpenTopography tutorial. In today's video, I will be discussing what is the difference between DEMs, DSMs, and DTMs. To begin, these two topographic hillshades show an area of northern Arizona with vegetation and mountains. The left shows a digital surface model, or DSM, where we can clearly see the vegetation above the mountains. The right shows a digital terrain model, or DTM, where the vegetation has been removed, and we can much better see the underlying mountainous landscape. So to begin, these three datasets, DEMs, DSMs, and DTMs, are all raster datasets. And this means they are a digital representation of the topography. The raster format refers to the data being stored as a grid of squares or pixels. For example, what you see on the right. In this case, the elevations are represented as a continuous surface along a regular X and Y grid. And it's important to note that these raster data sets are not true 3D. They're in fact called 2.5D, and that is because trees, cliffs, and other overhangs are represented with a single elevation, which simplifies the 3D structure of the feature. The raster data set on the right shows the elevation value, or the Z value, for each of these pixels. This represents a pyramid with the highest elevation being 400, and then decreasing elevation in all of the directions. So let's talk about in more detail what these products are and how you can make them on OpenTopography. So to start, DEM stands for Digital Elevation Model. And this is a fairly generic term, often refers to a raster dataset made from the full point cloud that represents an intermediate elevation between the bare earth and the high elevation. It's often made from a full point cloud using a local neighborhood, geostatistical, or spline method. A common approach is the triangular irregular network. And if you'd like to make this on OpenTopography, it is by far often the default option. A DSM stands for Digital Surface Model, and this represents the top of the landscape, and this can be made doing a local gridding of the maximum elevation. And in OpenTopography, you can make this by going to window number 6, selecting DEM generation, and then in the gridding method, taking the second option, which is to calculate the Zmax grid. A DTM, or digital terrain model, is representation of the bare earth and specifically measures the ground elevation with buildings and vegetation removed. DTMs are made with ground points only, often using the same method as a DEM. And to make this on OpenTopography, you can go to Coordinates and Classification, which is the first window, and select ground points. So let's look at an example of these in QGIS. So here I've loaded up topographic hillshades, and we're looking at a portion of downtown Phoenix, Arizona, with the basketball stadium and the baseball stadium. And here is the DEM, or digital elevation model. And this looks like we see features that we would often expect for a cityscape, including those sports complexes, a road, and here is even a crane. Here is now the digital surface model, or DSM, and this looks fairly similar to the DEM, but the DSM really looks like we're looking at the top surface of the area where we can see the details of the top of the buildings. And then here is the digital terrain model. And here we have holes where there's gaps in data at the buildings where there was no return, LiDAR returns from the ground surface. So we're now going to look at a topographic profile cutting through the sports stadiums. So here we have, again, looking at that topographic hillshade. And then in the bottom is a topographic profile showing elevation versus distance, where the DTM, digital terrain model, is green, DEM, digital elevation model, is red, and DSM, or digital surface model, is blue. And first we note that under the buildings, there's no elevation in the DTM, and that is because there were no recorded ground points beneath those buildings. The DEM and the DSM do look fairly similar. We note that the DSM is higher than the DEM, especially at the edges of buildings. Thank you. This concludes our video looking at different raster products.